So this falls into the category of, I never would have thought of that on my own. Or as I used to tell my teachers, I'm just going to pull that out of my, this is what you do. Hey there, you asked and I am here with it. We have more verifying trig identities. I've got a little cheat sheet I made for myself. These are the ones that I use most often. And the trick to doing identities in trig is to change everything into sines and cosines. And then just do a bunch of algebra until you get things working out. And by working out, what we're talking about is that you turn the left side into the right side. You are not solving equations here. You are just doing algebra gymnastics with these trig identities to make this pop out at the end. You do not touch the right side at all. We got to look at what we have. I know I have a secant, so I'll be using this because I need to turn it into its cosine version. I have a cotangent. I didn't write cotangent because I don't need to. If I have tangent as sine over cosine, I know cotangent is the same thing, just flipped over. So let's just rewrite these now. Secant x is going to turn into 1 over cos x. Cotangent x is going to turn into cosine x over sine x. Not sine over cosine, but cosine over sine. Now we look and see if there's anything we can do, and you're going to cancel things if you can. Cosine x is a number. If they're the same number, you can cancel them. What we're left with is 1 over sine x. And 1 over sine x looks familiar. It's right here. That turns into our target. Boom, we did it. And that's what you're going for, okay? Let's do it again. I actually think these are fun. They're like little puzzles. Okay, again, do not touch this side. That's your target. You got to turn everything into sines and cosines. I've got sines and cosines except for tangent. So let's replace that with its sine cosine version. Now we have to multiply. This is sine x over 1, which I'm not going to write. And that's being multiplied times sine x over cos x. So we get sine squared x over cos x plus cos x, which is still this one. It's just coming along for the ride. Now, I actually need to add these together, but they don't have a common denominator. So cos x over 1, and then I have to take the top and the bottom times another cos x because I need a cos x on the bottom to be able to add it to this. What you're going to end up with here on the top when I do it is cosine squared x. So I'm going to just write it out. All right, I got two fractions I need to add together that have the same denominator. So you add their numerators, and something, you should be getting some bells and whistles going off right now because look at what you have here. Sine squared x plus cosine squared x. That's your big Pythagorean identity in trigonometry. This whole thing turns into a 1. So now I'm down to 1 cos x. Oh, here's my target. I'm so close. 1 cos x is secant. Put a box around it. You are done. Everything falls apart somewhere. Like I just said, turn everything into sines and cosines. And you look at this and it's like, it's all sines and cosines already. You need to see people do these things first and then you'll learn. Look at your target. There's no sines over here. It's all cosine stuff. So I have cosine here, but I have a sine here. So this is the thing that needs to be rewritten in such a way that it's a cosine. Well, I don't have a formula for that directly, but if you play with your Pythagorean theorem, I just subtracted cosine from both sides. Sine squared theta equals 1 minus cosine squared theta. So I can anytime I see a sine squared theta, I can replace it with this. So that's what we're going to do. So instead of writing this, I write this. Nice. Now, I am famous for sign mistakes. So when I have to distribute a negative, I will put a little 1 here, especially when I'm teaching, because sometimes people don't follow what I'm doing. I am actually doing distributive property with a -1. So -1 times 1 will be -1 back. So let's write this out. We have cosine squared x minus 1, but it's a plus cosine squared x because a -1 times a negative cosine squared is going to change that sign to a positive. Now look, we have 2 cosines. Oh, one step, rewrite it. 2 cosine squared x minus 1 and put a box around it. We're done. We did it. Yay! Not done with the video because there's more that are not fun. You're looking at this going, it's all cosines and sines again. I know, but we have a target and we're starting out with something that looks too simple. Like there's nothing really to do here. This 1 plus cos x, I can't do anything with that. The Pythagorean theorem thing won't work. So this falls into the category of, I never would have thought of that on my own. Or as I used to tell my teachers, I'm just going to pull that out of my... This is what you do. We're going to use this little thing from algebra. It's probably forgotten math. A plus b times a minus b is a squared minus b squared. And once we get some stuff squaring with these sines and cosines, we're getting closer to being able to use this Pythagorean theorem. So how do we do this? We're going to take the top and the bottom. If you remember the word, it's called conjugate. We're going to do that. Top and bottom times the conjugate of the denominator. So 1 plus cosine x, we're going to multiply times 1 minus cos x. What we have on the top then is sine x times 1 minus cos x. And what we have on the bottom now is a squared minus b squared, 1 squared minus cosine squared x. Take a screenshot of this if you need to, because this is one of those things that a lot of people don't think of to do on their own. They need to have seen somebody else do it. All right, let's finish this up. 1 minus cos squared x looks familiar. Look at that. We already played with it. That just is going to turn into sine squared x. And we have sine x over 1 minus cos x. We're getting closer to our target. Can you see it? I have a sine x on the top and I have sine squared x on the bottom. If I cancel one of the signs, I'm canceling the square. Like just think of sine x times sine x and you're canceling one out. What you're left with is what we need. 1 minus cos x over sine x. Put a box around it. Pat yourself on the back because that one's difficult. And for bonus points, we're going to throw this one in here. Cosine of a minus b over sine a cos b equals this thing. So that's our target, cotangent a, tangent b. What can we do? What can we do? None of these are going to help me right now. This is a difference formula. So you're going to either memorize them for the week you have to know these, or you're going to go look it up. The cosine of two angles added together is this formula. Now I did this one on purpose because this one has this funky plus minus minus plus that you might see in a textbook. Cosine of a plus b will use the minus in the formula because it's on top. Cosine of a minus b, which is what we have here, is going to use the plus. So we'll do that. Now this next move is pretty common. You have two things being added together in the top in the numerator right here. This means this was two fractions that had the same denominator added together. So let's just split them apart again. You can probably guess what the next move is. If you look, you have some things that you can cancel. Like this one has cos b. And this one has sine a in both the numerator and the denominator. Let's cancel those. Your teacher's going to want you to probably write the line. I don't want to because I'm making a video and I don't want to run out of screen. So I'm just going to look at what's left here. I have cosine over sine of the same angle. And then I have sine over cosine of the other angle. That's what I need to have. But this is cotangent of a because it's cosine over sine. And this is tangent of b. Put a box around it. If this was useful for you, will you please share this with some other people who are in your class, especially if you guys are cramming for a quiz or a test or something. I've made other videos with different trig identities, so check these out if you want to see some more. Thanks for watching. I'll see you in the next one. Bye.